Alright, this video is about the law of sines. First of all, the law of sines is used when we have triangles that are not right triangles. However, they can be used for triangles that are right triangles. But generally, we reserve them for these kind of triangles, which are called oblique triangles. Alright, so oblique triangles are basically triangles that don't have a right angle in them. So it's kind of, all the angles are something other than 90 degrees. Something else to know about the law of sines is inside these triangles, the angles are represented by capital letters. So this angle means angle A, and the lowercase letter a is opposite of that angle. So this is capital A, lowercase a has to be opposite of it. This is capital B, lowercase b has to be opposite of it. And this is capital C, lowercase c has to be opposite of it. So you know where the sides are, they're opposite the uppercase letter. All right. Also, they're going to say things like solve the triangle. Solve the triangle basically means find all of the missing sides and angles. So whatever sides are unknown or whatever angles are known, you find them. All right, so really quickly, the law of sines is this. Sine of capital A over lowercase a is equal to sine of capital B over lowercase b, also equals to sine capital C over lowercase c. All right, so in order to use them, use law of sines, you have to have the angle on the side opposite of it, or somebody else's angle on the side opposite of it. You got to have one of the angles. So if you have this whole section going, like the angle A and the side A, or this whole section, angle B, side B, or angle C, side C, you have a matching pair, and you can use that for other sides. All right, I'm going to explain what that means in just a minute. But that's what law of sines formula is. I'll write that down someplace. Different books call it different things. You could reverse all of this, and you may see it written as A over sine of A equals B over sine of B equals C over sine of C. That's the same formula. There's a different author wrote it, and they chose to write it that way. You can switch whichever one you want, perfectly fine. As long as all of them switch, it's perfectly fine. It works as well. All right, so I'm about to erase this screen. All right, so here's an example. It says solve the triangle. Solve the triangle means find all missing sides and all missing angles. So I always start off by doing this. Right now, A, B, and C, capital, and then lowercase a, lowercase b, lowercase c, lowercase. So I will write that first, and then fill in all the blanks here. And when I fill in all the blanks, I know I'm done solving the triangle because I filled in all the blanks. So I know capital A is 118 degrees, so 118 degrees. I know capital B is 22 degrees. And I know that this is lowercase a, this is lowercase b, so this must be lowercase c. Why? Because they're opposite the angles. So this is capital B, this has to be lowercase b. That's capital A, this has to be lowercase a. That's capital C, that has to be lowercase c. So I know the lowercase c is 24. All right, so just looking at this, I have to have an angle on the side that matches in order to use law of sines. So I don't really have any right away. So you might want to see if you can figure out this third angle. One thing we know is all three of these angles have to add up to be 180 degrees. So I know that these two have to add to 180. So I know that 118 plus 22 adds up to 140 degrees. So that leaves me with 40 degrees left for this last angle, because the last angle's got to be what adds to be 180. So this has to be 40 degrees. So now that I know that's 40 degrees, I have a side and an angle, so I can start there. So I would start by writing up the equation. I would use C over sine of C and set that equal to B over sine of capital B. So the ratio for that, lowercase c is 24. Capital C is the angle 40 degrees, so it should be sine of 40 degrees. And I'll make sure my calculator is in degree mode now. And lowercase b I don't know, but I do know capital B is 22 degrees. So I can type in sine of 22 degrees. And basically you cross multiply, you finish solving that. All right, so So when I cross multiply, these multiply together and those multiply together, give you b times sine of 40 equals to 24 times sine of 22. And you can change these adjustments if you want. I'm going to leave them like they are. And if you want to finish this, I would divide both sides by sine 40. So I can isolate my b variable. So now these cancel. And you get b is equal to whatever this is. I'll plug in my calculator. All right, so you plugged in 24 sine 22. Oh, make that look a little better. 24 sine 22 divided by sine of 40 in your calculator should get b to be about 14. It's like 13.99 or something like that. So you should have got about 14. So I'm going to say b is 14. So this side is 14. And now you have enough information to find a. And if you didn't get 14, you probably have calculated in the wrong mode. So I had to figure out how to change my calculator to degree mode opposed to radians mode. But you should have got 14 had you plugged it in properly. All right, so now to find a, we'll do the same process. So I need to erase some of this stuff though. So I'm about to clear it out. So if you need it, I'll write it down before I erase it. All right, so to find lowercase a, I'll write down c over sine c again. And this time it's going to equal a over sine capital A. I'm going to fill it all in place. C over sine c is again 24 over sine 40. A over sine A should be unknown over sine of 118 degrees. And you're going to cross multiply. So basically, after you cross multiply, A should equal to 24 over sine of 40 times the sine of 118. You plug that directly, because when you cross multiply, this basically goes up, multiplies to that 24. So you can wind up getting this. So you plug that into your calculator, you should get about 33. It's a bit rounded up, but it's roughly 33. And that's it. That's how we use the law of sine if we want to find the sides. So this last piece is 33. And now we filled in all the information, so we saw the triangle. We found all the missing parts to it. All right, I'll get that as a note and give you one last example on law of sines, and that'll be it. Okay, new example. So solve this triangle. So it gave us capital A. This is lowercase a. Capital B we don't know, but this is lowercase b. Capital C we don't know, but this is lowercase c. I'm going to start with my two columns, A, B, and C. And lowercase a, b, and c. All right, and from there, I'm going to fill in what I know about those. Like I know uppercase A is 82 degrees. And I know that lowercase a is 29. Lowercase b is 24. And lowercase c is 20. All right, so I'm looking for the ones that match. I have a match here. I got a side and an angle for uppercase a and lowercase a. So using that information, I would say that a over sine of a equals a b over sine of b. I want to specifically use a because I know both parts of it. So I should have 29 over sine of 82 should equal to 24 over sine capital B. In this case, we're looking for angle. All right, so cross multiply. Now, if you cross multiply there, you should wind up having 29 sine of B equals to 24 sine 82. And from there, I want to isolate sine of B, so I got to divide both sides by what the number next to it. So we divide this by 29, divide that by 29. So these 29's cancel, leaving you with sine of b equals to 24 sine 82 over 29. I need to figure out what this value is. I'm out of space there, so I'm going to move it over here. So I found that sine of b has to equal to 0.8195, roughly. So to figure out what b is, I have to do sine inverse of both sides. And that leaves me with b, because these cancel. So b equals to the sine inverse, 0.8195. So b is about 55 degrees. So no, b is about 55 degrees. Well, I got two of the angles. How could you find the third angle? Well, you'll probably use the fact that all three had to be 180. So I know that 180 subtract 82. Do this a different way. So subtracting, let's go add together the ones we have. 82 and 55. Well, to add together with 137. So we take this 137, subtract it from 180. It's 43 degrees. So I'm going to find the answer is 43 degrees. So I've solved it. This is it. Those are all the missing parts of that triangle. All right, so anyway, that's the law of sines. And there's another part of the law of sines deals with the ambiguous case. We're going to talk about that in another video. That's the basic law of sines. But there's one more topic that deals with the ambiguous case. In a situation where you can have a second triangle being formed. Meaning you can have two different triangles considering information given. But that's another video. All right, that's all I have. Good luck.